So as Jim said, well, he didn't say, but I've actually been here 17 years, which is bizarre because I'm on like the 17th year of my 5-year Microsoft journey. Been around for a long time. I started the company working on the ASP.NET team. We then had the opportunity to move with Scott Guthrie, who was the EVP of Cloud and AI at Microsoft, to Azure in 2011 to work on tooling to make sure that ASP.NET ran great in Azure. And that kind of led, if you've been following .NET for a while, that led to something that was called .NET Core was kind of started while we were over in Azure. And then I came back to what's called Developer Division in 2016 to go finish that journey, shipping .NET Core 1.0 back then, and now we're on .NET 8. And at the Build conference a few months ago, we introduced .NET Aspire, which is funny. As I use it, I'm like, why did we not do this 5 years before? I don't know. But I'm here to talk about Aspire today. And I know there was a workshop. Did anybody go to the workshop, the Aspire workshop this week? See a few. Good. So we'll use a bunch of words that I don't like to start off with. You know, what makes an app cloud native? If I go talk to my customers, they're all like, all my apps are cloud native. I just put it in the cloud. It's in the cloud. But if you look, the CNCF has a lot of words here. But there's a couple of these words that I do think are important to me, and I'm going to call them out. I think resilient is a word that's important to me. And .NET has some great resiliency features that I'll talk about in it. Resilient means that, you know, when you're running on an on-prem server, stuff just works most of the time. If you're in the cloud, the network might be slow for 30 seconds for whatever reason. We don't know why. And so that's one thing about it. Observable is something that we've failed all of you customers for a long time. Observable means you have a good way of getting diagnostics of how your app's actually running. ASP.NET Web Forms had almost very little of that at all. When we built .NET Core, we put it in from the beginnings, .NET Core 1.0 all the way to now. We put that stuff in, but it was not on by default, and it was not very easy to go, you know, turn it on. And then, what other words do I like here? Microservice is a word I like here, and even manageable. And so let's drill this out. You're going to see the words I just talked about are kind of the ones we pop out here. That's our goals with Aspire, or to make the app observable. And I'll show a demo later. Observable does not mean just a web application. The telemetry we put into .NET works for WinForms, WPF, Maui, works for all those apps. And so, in fact, the dashboard we're going to show you works for all those types of apps as well. Obviously, resiliency I talked about before. Scalability is something that's another component of this. Having apps that can scale. We're not all the way there with .NET 8. We have work to do in .NET 9 and probably not .NET 10 to get all the way there. A scalable app typically has messaging, and you're sending messages into a tier, and that tier can scale up and down to do all those messages. And then there's manageability, which, you know, how do you manage the application? And you'll see me show you some of that in a second. I always laugh at this. This is the, you know, once again, the CNCF cloud native chart. That looks complex to me. That's like Microsoft 20 years ago. We'd start out every talk off with a diagram like this and talk about how we're going to make it work. Our job is to make it not that complex. And so, yeah, I'm not going to talk too much about this. You're going to see a whole bunch of namespaces and stuff like that. I don't want you to worry about these things. But you can see there's a whole bunch of namespaces around testing, telemetry, resilience, probes, and stuff like that. And I'm going to talk a little bit about how the fact that we actually put a lot of these features in .NET Core 3. But this is feedback that we do get from real customers. Too many things to choose from. I'm not sure if I'm using the things in the right way. Now you got to be an expert in networking, containers, telemetry. That's too much stuff, and nothing works together by default. I'll be very honest with you. One of the fun things about Aspire is Aspire is actually what we call an opinionated framework, meaning that we actually give you some of our opinions. We were afraid to give you opinions for a long time, because what if our opinions were wrong? And I'll talk about how we addressed the opinions in Aspire. And if you don't like our opinions, you can change our opinions. And so you can kind of hear from this, really, I want to solve, I don't want it to be super complex. I want it to be easy to get started. I don't want to give you too many choices. And I want you to have a paved path, which kind of goes together. And so that's what .NET Aspire actually is. And I would also tell people in the room, don't freak out. Aspire, as you're going to see, I don't have to throw my old app away and make an Aspire app. You can add Aspire to any application that you have today. It does not require a full reboot of life. And so, yeah. This is, you can see I'm about done with my slides at this point. I will talk about this a little bit. One of the things that we had an opinion on about Aspire is, if I come to Azure, and by the way, Aspire does work with other clouds as well. We made it extensible so other clouds could target it. AWS does have support for it, but I'm going to care about Azure because I work in Azure. We have lots of ways of running your compute in Azure. You can run in a virtual machine. You can run in an app service. You can run in a container app. You can run in a container instance. You can run in an AKS. There's lots of options. I don't want you to have to worry about what's the right option for you. And so what we did is we defaulted Aspire applications to container apps. Container apps is a technology that actually runs on Kubernetes, but we manage the Kubernetes for you. So, and so for most people getting started, you just throw your containers to us, and you don't have to worry about scalability. We've got a feature called Kata, which is our scaler. It does that. It's got, we got called embedded app patterns. If you've ever heard of Dapper's built in. And so a lot of things are built in, and we call it more dev, less ops. You don't have to really manage the thing. But there are people that want to use Kubernetes. It's an industry standard. It runs on all the clouds. And it has lots of access policies, lots of customizations. If you're a huge company and you're trying to, like, I'll give you an example in Microsoft, M365 runs an AKS, and it does because we scale that thing up and down to support the hundreds of millions of users that hit it. And we can save millions of dollars per month by doing that. None of the apps I've ever written have that kind of scale. But we have these two choices, and by right now, Aspire primarily works in container apps. There's some open source packages that will enable it to work in Kubernetes, and you'll see us make that a standard feature in the future as well. And then I'll throw in one more piece. My team built something. We did a fun thing a couple of years ago, about 2 years ago. I got a bunch of Python developers in a room, and I showed them an Azure sample and said, I want you to take this Azure sample and get it running in Azure. And 30 minutes later, not a single customer was able to get that application running in Azure. I would argue a .NET customer probably would have been luckier because we have so many great published features inside of Visual Studio. And so we built a tool that enables you to easily take applications and get them running in Azure. Because an app running in Azure might require a storage account. It might require a database. It might require an OpenAI instance. And this tool lets you define that in a folder, and it can create all those resources for you. And this is the tech that powers publishing an Aspire app to the cloud. Okay. And so I was laughing as I got up here on the computer, and the first thing that happened, I saw this. Oh, should I take an update? Literally came up today. I am not going to take the update. That would be a bad idea. Okay, so I was going to start with a fun app that I said I wrote with my friend Glenn Condron in .NET years ago. And what it is basically we were trying to make sure that a .NET application running in Azure or any cloud was not going to have problems if the network was slow. Maybe there was a glitch or something like that. And so if I go look at my code here, I have got a cool chunk of text that we wrote in here called the random fail middleware. It's basically something that I can inject in the pipeline of an app. And when I do that, it basically is going to throw errors on purpose. So, and what we do is we inject it in the application here. And so if I, let's see what mode we're in. If I run the app, you're going to see it's going to crash sometimes. It's going to work sometimes. And then we put features in .NET Core 3 to solve this exact problem. And so I want to show some other problems that we have with building microservices style apps in .NET today with our tools. Is I've got my back end, which you see right here. I've got my front end. To run these things together, I've got to do this configure startup project thing. And I can say I want to do multiples. This feature is not a great feature, by the way. I can say start without debugging, and do that. And now when I run it, it's going to run both the front end and the back end. But you might ask, how does this front end application, this web application, how does it get the port and the IP address of the app? And if I go look here, you're going to see that basically what I've done is I've got this nice hard-coded URL here, localhost 7138. And if you've been using .NET for a long time, you'll know you're going to find that somewhere in this launch settings file up here. I'm going to go find that port. Not exactly my favorite way. There's the 7138 right there. Hard-coded IP addresses, not good for your application. But I'm going to go and show that if let's start this app again. And now I should get two of these. There I am. I've got this. It's going to crash. My front end app's going to crash. So we built a feature in .NET Core 3, which I could solve this problem in. And so I'll go and just show you how we solve that in .NET Core 3. Very simple. All I've got to do is in my program.cs, for my API, I can just do this add transient HB error policy. But who in the room knew that feature existed? One hand. So hence the problem is we built all these great features and none of you knew they existed. And so if I run the app again, now the front end app is going to succeed, but there actually are errors happening. You just can't see them, but at least the app runs. And so that was the goal back then. So what would I do if I was going to do this with Aspire? So let's go make some Aspire changes here. And I think the most exciting thing to me about Aspire is I don't really have to change my app a whole bunch or at all. If I right click over here and I go to add, I can add Aspire orchestration support. And so to me, this is pretty crazy. I didn't change the app. I just took my existing ASP.NET app, ASP.NET Core app, and right clicked and said I want to make it an Aspire application, and not a lot changed. If I go look, you probably saw a couple things here. The things that changed is I got 2 new projects. And it bolded this app host project. So let's do some zoomification here. And so you see I've got these new projects. Well, let's go look at my original app and let's see what actually changed. If I go to program.cs, I can see 2 changes. Builder.add service defaults. I mentioned before we were afraid to have opinions. Well, now we've taken all of our opinions and we put them into a project. And so one of the projects that gets added is this service defaults project. And if I open the code up for this, what you're going to see inside of here is we're going to configure open telemetry. That's a feature we put in about 2 versions ago. You can see that it's got default health checks. Health checks is a feature. Any of these cloud platforms have the ability to call an endpoint to ask the app, is the app healthy? If the app says, no, I'm not healthy, or doesn't respond, the container host will restart the application automatically. Service discovery. I just showed you a second ago, I showed you hard-coded URLs. While those might run locally, if I push those into any cloud, they're going to fail because there is no local host. There is no whatever those ports are. And then you're going to see here This is when we add that same resiliency I added before manually in the .NET Core 3 project. That's here on by default as well. And then down here, you'll see this is the stuff that configures the open telemetry. And I'll explain in a little bit more what that is. But and so all we've done is said any project that you add Aspire to is going to get telemetry by default. It's going to get health checks by default. It's going to get service discovery, which I'm going to show you is a way not to have to hard code names and URLs. And it's going to get resilience by default. If you want to change any of these, you can change them as much as you want. That's why they're in their own project. And so, but if I go back here and look, there's also a call to map endpoints. And that's because things like health checks have endpoints and stuff like that. But that's the only change. 2 lines of code were added to my program.cs in my existing application. Now I did get this new app, this app host. And of course, all my projects are going to refer, there'll be a dependency to that service defaults. That's going to be there. But notice I also got this new project, and it's bolded, which means it's the project that's going to be run by the tool by default. And if I go look at it, it's going to have a distributed application builder, very similar to the builders we have in an ASP.NET Core application. And it's got a reference to my one project that I right-clicked on, the fail API, and it's ready to go. So not a lot of changes. And if I run it, you will see a little bit of change. Let's run it for fun. And so one of the big differences now is I have a dashboard that I did not have before. And so my dashboard's got my 2 endpoints inside of it. In my dashboard, I can go look at the logs for the application that's running. In my dashboard, I can go view all the environment for the app that's running. And I'll drill into this a little bit more in a little bit. I haven't run any code yet. I've not run anything at all, so you really can't see much here. But let's go over here to the endpoint. I'll open the endpoint up, and we'll run it a few times, get a few results, get a bunch of errors. Good. Now, what's really cool here, now I can go to my structured logs, and notice I see all these errors. And so before, those errors were kind of transparent to my application. They're invisible. I had no access to them. The traces are even cooler. If I go look at the traces, because you'll see the call, it makes the call. You see that a few times it had to call the API 2 times to get a proper response back for this. So we give you a much better view in logs. And now if I go down to metrics, I can do this and see a bunch of stuff like this. So now I can see a bunch of Kestrel stuff and all the stuff running behind the scenes to make the app run. And so that's a huge improvement. So let's go take the other app and get the other app Aspire-ified as well. Okay, so I'm going to go to my retry app, and I'll right-click and I'll do the same thing. I'm going to add Aspire orchestration support. I'll say yes. And notice, if you notice, I've still got this app host program.cs open up. And now I've got 2 of these things. I've got the fail API and I've got the retry application. So you can see it's building. This is when we start. These are all the things that we're going to start. But let's make a couple of other changes while we're here. So first off, I showed before I had these awful hard-coded things. So now I don't have to have this hard-coded thing. I can get rid of this. And I can just say, this is going to be fail API. This is what service discovery does. And technically, because I'm going to run in the cloud, I don't even need that at all. So what happens now is any name I give something over in my app host, that flows through. This is service discovery. So I've got one API called fail API. That name is magically converts to whatever IP address. I've got retry app. If I wanted to call from the API back to the front end app, it could do that as well. But I need to do a little bit more over here as well. So let's go and do one more thing. I kind of want to give things, dependencies. And so there's a whole bunch of cool things here. Let's go look at some of the stuff that we have here. So there's with reference. And so what I'm saying here is I want this not to have a slash. I want this to reference the API. That tells the system what order to run these apps in. It's going to start the API up first, then it's going to start the web front end up. And I might also, in the future, I might publish this to the internet. And so what I'm telling it now is I'm telling it, hey, I want my front end to reference the API, and I want my front end to actually have external access. When I publish this to a cloud, I don't want the API to be visible, but I want the front end to be visible. So I've given it these two things. So I've set all the dependencies up, and so we're good to go. And so now I can do, let's start the app up again. Oh, let's do one thing too. I can turn off this stuff. I don't need to add this anymore because the system's going to do it for me. Okay. So now my dashboard is going to come up. I've got both apps. I've got the back end. I've got the front end. I can click the front end. It ran, good. Notice there was a pause there. I'm going to guess that maybe it had an error. So let's go look, because we now have these structured logs. You can see there was an error. And notice that I have here a resilience event occurred. So that resiliency is now on with those service defaults automatically. My entire app runs. It's crashing, but I can now see the crashes. So you might ask next, well, what if I want to put this on the internet? What would I have to go do in the cloud? What would I have to do? So let's go do that. So I could be the developer that I want to show you folks how this actually works. I could obviously go up here and I could right click and I can do a publish right from here. Well, actually, I shouldn't do that. I should actually click on the app host here. I can do a publish here. We're going to detect that this application is, nope. And notice it says, container for .NET Aspire. Notice I didn't have to do anything. That's built in. I want to show you how it actually works under the covers, though. So I'm not going to do that right now. So let's go to source, retry app. Okay. Random fail. So I want to show you how that right-click publish actually works under the covers, because I think it's interesting and it's very useful for folks. I'm going to run AZD init. AZD is the Azure Developer CLI. That's what it stands for, Azure Developer. I'm going to run AZD init. And technically, when you right-click publish inside of Visual Studio and Aspire application, it does this exact thing. I want to show you how it works, because one of our goals with Aspire was, what if I'm in VS Code? What if I'm using some other editor? You can use whatever. We don't care. All the tech runs from the command line. Notice that it says it found an Aspire application. And I'll say this is CSH random fail. I give it a name. And now it's gone and created all the magic for me to publish this to Azure. But maybe you want to see what it actually does. So I'm going to run another command, AZD infrasenth. And so what happens is when you do an AZD init, we actually do all the right stuff to go figure out how to publish your app for you. But maybe you're an IT person and you want to actually see what are the actual files, what bicep files. Bicep is the language of Azure. What bicep files are actually created here? Well, we have another command I can run, AZD infrasenth. In that case, it's going to make those files available to me. So by default, you don't see the files. But in this particular case, notice I have this folder. I have a folder called infra. And inside of it, there's going to be the bicep files that actually are used to create all these resources. And so the idea here is if you're a dev/IT person, or you want to give your IT people the actual glue that's going to publish this thing to Azure, it's right here for you to play with. And then what I would do is I can come over here, close that down, and I can do an AZD up. And now it's going to go take a look at this application and do the right things to get it running in the cloud. And you can see that I'm already on subscription 27. I think I have 130. I'm going to choose my subscription. And I'll choose a location. And up we're going to go. I'm not going to, I'll do some other stuff while we're waiting for this, but this is going to publish the app to Azure. Now, one of the cool things here, let's say you added another project to your Aspire solution. And you ran AZD up again or right-click published again. It'll publish all the apps. So we actually watch what's actually in the application. And as you add more stuff, we will go and do the additive for you inside of the cloud. So while that's running, I want to show you a couple of other cool features while we're here. So while that's waiting, I want to show you, what should I show you? I'm going to show you a different flavor of this. This is what I call Aspire with Services. And so in this case, I've got something a little different here. If I'm on my app host, I can right click on an app host and I can come over here and go add. And notice there's a .NET Aspire package. And this is where things get really interesting to me is you're going to see all kinds of cool stuff here. Here's a Redis cache. Here is a SQL server. Here's a PostgreSQL, a RabbitMQ, Dapper, Azure Storage, Application Insights, Service Bus, cognitive services, if you're doing AI, Cosmos DB, Orleans. We have built a bunch of components for your Aspire applications. And Aspire does what we call infrastructure as code. And so notice in my app host, and this is a much more complicated sample here. Once again, I've got my project right here, my web front end, but up here I did a blob. I went and created Azure Storage. I said run as emulator. That means when I run the application locally, we're going to run an emulator in a container for you, so you don't have to actually have a real Azure Storage while you're running locally. And I added a blob to it. I also created a Redis cache. I've got my API service, and then I've got my web front end. And my web front end depends on the cache, it depends on the API service, and it depends on the blobs. So let's run this locally and see what happens. Give it a second, and we go boom. All right. So it's complaining that it doesn't find Docker. I don't know if Docker started earlier when I tried to start it. It is not running here. Let's rerun Docker. So running this is going to require Docker because I need containers for my cache and my storage emulator. And so let's get Docker a chance to launch. And for fun, for anybody that's out there, this is one of these fancy new machines. And so notice that this is actually an ARM machine. So, and these are awesome, I will tell you. Okay, so let's try this again. Going a little further now. Okay, so now if you look here, notice I've got a bunch of stuff. Not only do I have my two projects, my API and my front end, I've now got a container running the storage emulator, I've got a container running the cache, and I've got my blobs, which is based on those two things. And so cool thing here is I can develop locally with a SQL database, a Postgres database, a MySQL database. You don't have to install any of that stuff on your machine. We just run it all in containers on the box. Let's go look and see how we're doing over here. Still going. But I want to show one more aspect of this too. One of the things that is also super interesting is this is a complicated app that's using some Azure features. When I run it locally, it just runs these in containers. If I publish this to Azure, I'm going to see something totally different. I published this before because I don't want us to wait for a bunch of publishes here. I'm going to go and look at the app with services. I'm going to do a resource visualizer of this. And notice that I have, and this is a key component of this. When I want to use the storage account, I reference the name inside of that app host. I don't have to go wonder what the connection string for the storage is. And even better, one of the things that you might have heard about is, we at Microsoft are all supposed to be doing security stuff now. And so we should be using best practices. We want to make sure your app, when you run it in Azure, uses the best practice. And so the best practice for using storage is to use something called managed identity. In the case of managed identity, there is no connection string. Because I basically defined and said, this web application is allowed to talk to this storage account. I do that at the infrastructure level. And because of that, there is nothing that can be hacked because there's no string, there's no password, there's nothing. And so notice that this app, it's got a web front end, it's got a cache, it's got the API, and here it is. Here's my managed identity for the storage, which is hiding somewhere over here. And so we're doing best practices. You don't have to worry about, do I understand what a key vault is or how to use that or how managed identity works. You just reference the components for all the Azure bits you want to use in your application's app host. And when you publish, we'll make sure we do the best model for doing that application. Okay, look at this. The app is published. So this app is published. And so now where this gets really interesting to me is, notice that on the publish, I also get a link to the dashboard. So it would have been one thing to have a dashboard just for local development. But really, I want that same dashboard to follow you all the way to Azure. And so we actually run the Aspire dashboard in the cloud. And so notice now that my URL is definitely up in the Azure Container Apps space. And I can go click the URL. This should launch my front end. There the front end is. And remember, if I go back to the source code for random fail and I look at my app host, remember, I did not make the API public. Only this project here, the retry app, has the external HTTP endpoints, which means if I go back to the dashboard and try to access the API, that doesn't exist. It's not public. It's secure by default. The front end works just like you saw here. And now, to me, the nice thing is, it's likely to be having some wobbles there. If I go to my traces, there you go. I see all my traces, all the stuff. So now I can go to the portal and actually see in Azure if my app is having trouble or not. And even better, in the future, we're going to have a mechanism where you can actually, the only negative of the dashboard we have, it's in memory. So it's only going to keep like a day's worth of data. If you want to keep weeks worth of data, you'll have to upgrade to something like Azure App Insights, which actually has storage associated with it. But the app was resilient. It didn't show the crashes. You see the crashes here on the page. But at least I can come over here and diagnose what's going on with this thing. And so to me, it's super cool that you can actually get the dashboard not only locally, but in the cloud. But the dashboard's even better than that. Let's go move down to here. And what I'll do is I will switch us back to this one. And we'll go here. And I'm going to run a standalone dashboard. And so in this case, this is a console application. But the console application, if I go look at the code for it, it's got a chunk of code, basically the same code that you saw in the service defaults for the web application. And my console application can use the dashboard the same way. And so what I can do here, I did have it running earlier, but the reboot probably wiped that out. I don't have any containers. So what I'm going to do here is I'm going to cheat a little bit. And I will go over here and I'm going to grab this. I will show you the post where we actually explain how this works. What I can do is I can go to a terminal, any terminal, and I can decide to start the dashboard on my computer. And so whether you're running a WinForm app, an ASP.NET app, whatever, I can basically start the dashboard. I just started it. If I go back into my Docker and I look at my containers, there is the dashboard. I can click on the dashboard, and I need to get one thing here that's important here. Notice that there's this login. We want the dashboard to be secure because the dashboard has access to lots of information. I'm going to copy this key. I'll do that. And then we'll go back. I kind of messed myself up because I'm going to grab this first too. So I'm going to get the dashboard running in my browser. And it wants that token. So let's go get that token out of the container logs here. And this is just to make sure you can't just have a random dashboard running on somebody's computer that can steal and get into stuff. So that is not invalid. I missed a 2. Oops. Okay. There we are. Same dashboard you saw before. But now if I just go run my app over here, this is a console app that goes and does some NuGet processing. Bingo. Right in my dashboard. There's people, there's blog posts out there of people that are actually just doing local ASP.NET development. They're not doing any Aspire at all. They turn this on and they run the dashboard on one monitor and they run their ASP.NET application and VS in the other, on the other monitor, and they just have the dashboard running all the time side by side. And so we developed the dashboard to be run standalone, just like I showed you. It can run in any app, WinForm, WPF, all the apps. Something else that's interesting as we play with this tech is let's go look at something else is not only can we run containers and projects, we can also run executables. And this is super important because one of the other goals we had is some of the most popular templates we've had in ASP.NET over the years have been our templates for doing React, Angular, and Vue. And we want to make sure that with Aspire, you have access to that stuff too. So I can come over here and I'm going to jump down to Aspire JavaScript. And if I go look at my app host, this app host, notice it's going to add what we call an NPM app. So there's an Angular app, there is a Vue app, and there's a React app here. I will tell you right now that only 2 of these will actually run on my computer. The Angular app depends on binaries, and there is no ARM64 version of those binaries. And so that's not going to work. But in this case, I'm doing the same thing. I was going to say, yeah, there we go. Expecting that red icon on the Angular app because it should die. But this is basically just a React app wired to the same ASP.NET Core Web API, and or I can do the view weather as well. And so just trying to show you that this technology is not limited just to .NET. We can run any container with any technology in it, Postgres, MySQL, whatever. We can run executables. In this case, we're going out and running Node.js-based applications. And once again, you see that in the dashboard as well here. Instead of saying container or project, it says executable. And so we've made this technology super, super rich. Where I like to always end these things on is the ultimate crazy application. How far can we go with this stuff? And I'm going to go launch this app. And this is eShop. The eShop was a template we built years and years ago for showing that you could build microservice-based applications in .NET. I want to show you how complex of an application you can actually run here. So this is an application with a whole pile of microservices. I can once again drill down into my app host. And you're going to see I've got a Redis, I've got a RabbitMQ, I've got a Postgres, I've got a bunch of services, an identity API, a basket API, catalog API, projects for web and all kinds of stuff. This is a complicated application. Here's the web app. It depends on the basket, the catalog, the ordering, the RabbitMQ. Now what's cool is, once again, this might fail the first time. I had the machine warmed up before. We'll see if it comes up the first time or not. It's got to start a lot of containers. We might get lucky. And so now you're looking at a very complex Aspire application right here with lots of services running. And I can click on the link to this. There's my home page. All the stuff works. That's a pretty fast Control 5 experience for a 15 or 16 microservice application, running some databases, and all that kind of stuff. And once again, I still have access to all of this information from the dashboard. And so this was us trying to make sure this thing scaled to handle these big applications. And for fun, I have this same application. Yeah, I know you're gone. If I go to, I've got this app running in Azure as well. That same publish, right-click publish, it'll publish that entire complex application. I don't have to publish 15 times. I publish once, I get the entire application. Here you can see all the resources. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 containers. It's got managed identity for security again. And so this is a huge, complicated application running up in Azure. And I can drop into the main web application. Here it is. Now I've got an Azure API. And in this case, what I actually did for the app is I did do our typical right-click publish, which ran that AZD up behind the scenes. And if I give it enough time here, it's going to go out. You can see down here, it's doing the restore first, but it's also going to go out, and it says right now, it says Azure resources are not provisioned yet. It will, when the circle up here stops spinning, it's actually out there querying Azure right now for all the pieces of the app that are up there. And when it gets them, it will actually display each component of the app. It'll give you the Azure URL, all inside of Visual Studio. Super simple to get access to. And it says failed. Try again. There's a lot of stuff there, and so it takes a while for it to go pull that. That's an area where Aspire can get better is we do struggle sometimes with these multi-part applications. Sometimes we see the process start up, but it's not responding yet. And so we get some kind of like race condition kind of errors. Those are things you're going to see the team get better at as we move on. And so let's go back, since the reboot kind of killed us. So what I tell people is, grab the latest Visual Studio, update it today, install .NET 8 and Aspire, go build some microservices and get them up in container apps in minutes. Show your boss and get showered in awe and amazement, because I do think it's amazing that nowhere before in .NET could I go build a multi-part application and in a single gesture publish it to Azure. Nowhere before could I actually take that same application and go get the bicep or ARM files that are used to deploy it to Azure. Nowhere before could I get a great dashboard that shows me if the app is running locally, both locally and in the cloud. Nowhere before did I have the ability to do all that service discovery where I don't have to use hard-coded IP addresses and ports. I can really quickly, just before we go, I can show you how that actually worked. I never showed how that worked. Let's go back to the retry app. I'll run it locally, and I'll show you. You might ask, how do we convert failed API to an IP address? So let's go open up the random fail app here. I will run it and show you the dashboard, because this is all sitting in the dashboard. If I go look at this app, and before, remember, I changed those URLs from being hard-coded, these other things. If I go look at the front-end application and I scroll through here, notice that I'm going to have an environment variable in a second here. Services fail API. And if I click to show these, there you go. So what we do is we inject environment variables into the applications with the actual real ports and addresses they're running on, and we use code to convert those back and forth. But with that, I will go back to the slide and show the final slide, which is I'm supposed to show these QR codes. Please go and scan the code and give feedback. I'm going to be around for the next 30 or 40 minutes. If you have any questions about ASP.NET, .NET, Aspire, how we got where we are today, please come by and talk to me. I would love to chat with you. Thank you, folks.